Welcome to This Explainer. Okay, today we're diving into a truly wild idea. Think about your laptop, your phone, or those massive server farms keeping the internet running. What if they aren't just machines anymore? What if they've evolved into something way more organic? Today we're going to dissect exactly how malicious code actually imitates life. And we'll see why treating our networks like literal biological ecosystems is pretty much the only way to understand and survive the threats we're facing out there.
So why are modern computer networks acting less like machines and more like living, breathing ecosystems under constant predator threat? It's kind of a mind-bending shift in perspective, right? Instead of looking at the internet as just this sterile series of tubes and wires, we're going to explore this digital landscape like it's a nature documentary. We're tracking predators in the wild, and let me tell you, they are incredibly hungry.
Section 1. The Digital Ecosystem, Code Imitating Life. All right, let's dive into this. To really get a handle on the threats facing our devices today, we gotta stop thinking like traditional computer scientists for a second and start thinking like biologists. We literally need to translate our vocabulary. Like, we toss around the word antivirus all the time, right? But what we're actually talking about is an immune system. When we say malware, we really should be picturing a pathogen. Anchoring ourselves in this biological metaphor changes everything about how we look at digital attacks. It forces us to realize, hey, we aren't just dealing with a software glitch or some bad strings of code, we're dealing with a living entity that is actively attacking a host organism. This paradigm shift, it's the absolute foundation for analyzing how modern digital threats operate.
Moving on to Section 2, Worms, Exponential Pathogens.
Let's meet our first digital predator, worms. These guys function exactly like a highly contagious biological pathogen moving through a crowded room. Their life cycle is brutal and, honestly, incredibly simplistic. First, they scan the network, basically sniffing the digital air, looking for a vulnerable host. They're constantly probing for any open port or unpatched service. The absolute split second they find a security failure, just a tiny gap in the firewall defenses, boom, they breach it. And then they propagate. See, they don't just attack a single point or wait for a user to foolishly click a file. No, they hijack the host's resources to automatically launch that exact same attack on the very next vulnerable system.
Now, the absolutely crucial point here is that term right there, exponential growth. Once that initial security failure gets exploited, we are looking at rapid, totally unrestrained network infection. It's not just one worm crawling slowly through a wire. Think about massive historical outbreaks like WannaCry or the Morris worm. One infected machine immediately scans and infects 10 others. Then those 10 infect 100. Those 100 infect 10,000. You get the idea. It spreads literally at the speed of light. Before human network administrators can even fully comprehend that an outbreak is started, the entire ecosystem is just overwhelmed and brought to its knees by sheer volume.
Which brings us to Section 3, Rootkits, the immune suppressors.
As we trek deeper into this digital jungle, we run into a much stealthier threat, one that targets the exact anatomical center of the machine, the kernel. Now, as you probably know, the kernel is the absolute brain of the operating system. It orchestrates every single hardware and software interaction. But let's think about this biologically for a second. Imagine if a physical virus actually manages to cross the blood-brain barrier and seize the physical brain. It instantly controls every single bodily function. The host doesn't even know it's sick, because the very organ responsible for realizing something is wrong has been completely compromised. That right there is the singular devastating goal of a rootkit. Once it breaches that core, its behavior mimics real-world immunodeficiency viruses flawlessly. It hides deep inside the kernel, and from that incredibly privileged position, it actively deactivates your antivirus immune systems. By literally shutting down the host's defenses from the inside out, the rootkit makes its own removal nearly impossible. The system's alarm bells, they've been surgically disconnected. Any diagnostic tool you run relies on the kernel to tell it the truth, but the kernel is now actively lying to protect the parasite. It is a terrifying masterclass in parasitic survival and stealth.
Up next is Section 4, Fileless Malware, Invisible Predators. If the rootkit is an immune suppressor, fileless malware is the true phantom of the ecosystem. I mean, it is the absolute apex of digital stealth evolution. To understand why, you really have to look closely at its hunting ground. Traditional malicious code that's written to a hard drive leaves a physical data trail. It drops executable files, it edits registry keys. Basically, it leaves footprints in the mud for forensic investigators to follow. But by targeting RAM, this predator operates entirely in a volatile environment. It completely bypasses traditional file scanning and leaves absolutely zero physical trail behind. Because it resides exclusively in the computer's memory, or RAM, it essentially hijacks the legitimate tools that are already running in the system's memory space to do all of its dirty work. It's like a parasite that uses the host's own cellular machinery without bringing any of its own tools to the job. And here is where it gets truly, truly insidious. When the power is cut and the system reboots, the memory wipes, and the predator just evaporates into thin air. It vanishes entirely, leaving incident responders and security teams with absolutely zero physical evidence on the hard drive that it was ever even there. Crazy, right?
Let's zoom out in Section 5, the evolutionary arms race.
Zooming out from these individual threats, we start to realize that we aren't just patching software and updating firewalls anymore. We are locked in exactly what this quote describes: a digital evolutionary arms race. This isn't just a static game of cat and mouse, it's an endless, escalating cycle of adaptation and survival. Literally, every single time our digital immune systems get a little bit stronger, the pathogens mutate. We build better antivirus heuristics, and they develop fileless memory architectures. They are continually evolving to become faster, stealthier, and incredibly resilient to our countermeasures.
So the ultimate takeaway from all this is this: malicious code behaves exactly like biological pathogens seeking hosts to replicate their genetic instructions. At its very core, this code is driven by the exact same biological imperative as a real-world virus. It's not just lines of text sitting passively on a server somewhere. It wants to survive, it wants to adapt to its environment, and above all else, it wants to multiply. We are literally witnessing life, simulated and weaponized through code, constantly pressing against the boundaries of our digital defenses.
Which leaves us with a lingering and, frankly, a pretty unnerving thought. Is the device you are using right now just a tool, or is it a host in an evolutionary war? Think about that. The next time you open your laptop or tap on your phone, remember, you are holding a living ecosystem. And out there in the dark, the predators are always evolving. Well, thank you so much for joining me for this explainer. Stay curious, and please keep your digital immune system strong.